Welcome ladies and gentlemen. In video number 106 I performed graphical analysis of categorical data, and I made a number of graphs including bar graph and others. In this video I am going to use graphical analysis for quantitative data, and instead of categorical variables here I would like to use some scale or numeric or quantitative data, and I will make some graphs of these variables. So ladies and gentlemen, let me open my STATA file, and here is the file. Before I analyze quantitative data graphically, let me again show you the data. This is the data. In my earlier video I analyzed these categorical variables including female, race, socioeconomic status, school type, program type, and so on. Now I will analyze these variables: reading score, writing score, score in mathematics, score in science, score in social sciences. These are quantitative variables. So I would like to analyze these quantitative variables. Usually when we have quantitative data, we don't make cross-fit tabulation, or we don't calculate or compute a Pearson chi-square test, but here instead we compute coefficient of correlation between two quantitative variables. So let me start with the data analysis. I will close this. So let me go to statistics, and here under this I would go to pairwise correlation. So let me see, let me use this and this, and can I also use this and this and this? So let me see. Yes, I gave this command to STATA, and this is pairwise correlation between reading, writing, mathematics, science, social studies, and then I use significance for star at 5% level. Now here column wise I have 5 variables: read, write, math, science, and social studies. Similarly row wise I have also 5 variables, same variables: read, write, math, science, and social studies. These, along the principal diagonal, we see that the correlation coefficient is equal to 1, and this is because of the reason that the correlation coefficient between read and read must be exactly equal to 1. Similarly, the correlation coefficient between write and write, between math and math, between science and science, and between social studies and social studies must be equal to 1. So that is why we have correlation coefficients equal to 1 along the main diagonal or principal diagonal. Below the principal diagonal we see coefficient of correlations between various variables like read and write. This correlation coefficient is 0.59, and this is significant at 5%. Similarly, this correlation coefficient between read and math, and this is also significant. Similarly, this is the correlation coefficient between write and math. This is also significant. This is the correlation coefficient between read and science, write and science, math and science, and all of them are significant. Similarly, all these correlation coefficients are significant at least at 5% level. They are also significant at 1 and 0.01 level. So now let me also try graphic analysis of some of these variables. So let me go to graph, and since these are quantitative variables, so I'm going to use a histogram. So let me use a histogram of the variable read, and let me submit it. Now this is the histogram of sample respondents by reading score, and above these bars you see these are the number of frequencies, and I can change these into percent. If I click on this, these are now percentages. I can also change these into fractions. Now these are the fractions, and similarly I can also change these into density. Now these values will be density. Anyway, most likely we will be either using frequencies or percentages. So these are the frequencies, actual frequencies, and if I click on percent, these are the percentage values. So this is the histogram of reading score of the sample respondent. I can also change these into, say for example, instead of 10, let me make this 15, and let me see what happens. So if I click this, then the histogram changes like this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So we can change the number of bins, and here I can use this, say for example 8. So then this is my histogram, or I can also set other limits, but anyway this is how we can make a histogram. Now I would also like to the y-axis, and here I can write, say for example, frequency, and then it will change. So now here this is frequency, so I will also change this here. So you see this is along the y-axis we have frequencies, and above these bars you see the frequencies, and along the x-axis we measure reading score. Now let me change this from read to, say, write. This is my other variable, and let me change this into 10, and now I will also like to change the title, because now this is not a reading score, this is a writing score. So the title should be writing score. I will change this, and when I submit it, the title will be changed. So now the title has been changed from reading score to writing score. And I can also, let me see, change these let me see, I can change this into percent. So now you will see distribution of sample respondents by writing score, and now you can see these are the frequencies, sorry, these are the percentages. And I can also change now y-axis, instead of frequency I will write percent, so that the y-axis will change from frequency to percent. So here we can change frequency into percent. These are percentages. Similarly, we can go back and change these percentages into frequency, and then I will write here frequency, and similarly I will click on frequency. Now percentage will be changed into frequencies. So here is frequency, and here all these are frequencies. We can also change these into say 12. So the number of bins will be 12 now, and here is the histogram of writing score of the sample respondents. I can also do one more thing. If now I want to make a histogram but only for the female, so I will write female is equal to 1. So I'm asking the STATA to make a histogram for the data only for the female students or candidates. So now this is the histogram of those who are female. So this is the writing score of the female students. Let me make also this for male students. Now this will be changed. Now this is the histogram of writing score of the sample respondent for the male students, and if I remove this, then it will be histogram for the whole sample. So there is no specification about male and female. Similarly, I can also make this for private schools. So let me write school type CHTYPE is equal 1. Now this is for public schools, and I can also make this for private schools. So I will specify 2. Now this is histogram of writing score of the candidates from private schools. I can also change this into program type. So PROG1. I only want to make a histogram of these students in general program. So this is the histogram of writing score only in the general program. Let me change this into academic. So this will change. Now this is the histogram of writing score in academic program, and I can also check this for vocational. So this is histogram of writing score of the sample respondents who are studying in vocational institutes. So this is how we can change specification of the histograms and so on. Let me also try another type of graph. So let me close this. And this time, instead of histogram, I want to make box plot for say the science or say math. So here is my variable. Let me write math, and let me submit it. So here is the box plot of the math score. I can also make some other graphs. Say for example box plot, contour plot, and scatter matrix. And in scatter matrix, let me use all of these variables: read, write, math, science, and also social studies. Let me click this. Here is the scatter matrix of the various variables. So Let me see what happens now. This is a reading score, this is writing score. So this is the matrix between these two, and this is between writing and math score, this is between math score and reading score, and this is between reading score and writing score, and this is between science score and math score, this is between science score and writing score, and this is between science score and reading score. Similarly, social studies score and science score, social studies score and math score, social studies score and writing score, and social studies score and reading score. So these are the various types of graphic analysis which we can use for quantitative variables or scale variables. You can also change the titles, you can also change the frequencies and percentages and so on. Ladies and gentlemen, you can play with your data. You can make different types of graphs which you can use in your thesis, in your paper, and that depends upon which kind of graph would be suitable for your analysis. STATA is very helpful in making these graphs, and you can learn by playing with your data and try different types of graphs, different types of if and then, say for example male, female, race, socioeconomic status, school type, and so on. If you like the video, you can share this with your friends, with your colleagues, with your students. Kindly do subscribe to the channel and don't forget to click on bell icon so that you can get notification about my other videos that I may be uploading in future. Thank you, and have a good afternoon.